Welcome to Evil Dojo. I am your host, the ghost with the most gnosis, diagnosis, halitosis. Apropos, we on the go. What it do, buckaroos? I'm going to be doing recording for this video throughout the day, but long story short, I've made a lot of progress since last time I checked in with y'all. Here we have some gameplay from the current state of the game. Shotgun effect in full force. Eyeballs requiring multiple hits in order to get killed, and a nice little explosion animation on hit contact, as well as a red enemy flash. Today I'm going to take you through a recording of some development I did a couple days ago. And I'm going to be stepping through this recording throughout the day in little parts as I have free available time. I'm going to have to take a momentary break, but you, the viewer, should not notice anything in this regard. I'm trying to do things in a way that will allow me to kind of move at my own pace so I can bring you the highest quality product without having to make any sacrifices due to my time constraints. All right, back to it for real. So, first thing I end up doing here is taking a look at the state of the game over screen. Game over text is centered correctly, but not aligned in the very center of the screen. So we're going to fix that. First thing we do is take a look at the render game over function. Very simple, straightforward function that all it does is render a texture to the screen at a certain position. Position specified by the XY, which is target texture destination width divided by 4. I'm going to play around with this number, set it to 0 instead. Because ideally, we just stretch the entire texture across the entire window. Very straightforward. In the very beginning, I want to comment out everything except for the render game over function. That is the only thing that we see to begin with. This will make testing a lot faster. See, now it's aligned at the top left, so my assumptions about the positioning system are correct. But now, I'm going to go back and fiddle with these numbers to get it centered exactly on the screen. In order to do this, we have to figure out the appropriate X and Y positions. The Y position is essentially going to be about halfway through the screen. So what we can do is take window height divided by 2 and then subtract half of the height of the text texture itself from that Y value. We'll do a similar thing for the X. Essentially what we're doing is making use of the current window width and height in order to figure out exactly where we want to position this text. I know it's a very pedantic detail, but you want to be pedantically detailed when it comes to these elements. It's just a simple text texture. It's really not a big deal, but at the same time, this is also basic math. This is simply applying geometry concepts in practice. There we go. Now we actually have a properly centered game over text. It's funny that it requires that much work just to center text, but as you can see, it stays centered whether or not the screen is currently windowed. And this means that we can very quickly create dynamic screens to display different pieces of information. I go ahead and make my commit message to Git and check it in. We'll go ahead and call that a checkpoint. Alright, what's next? I open up my components.h file. I forget exactly what I was doing here. I took notes on exactly at what point certain things happened previously, but I'm doing this on the fly at the moment. Oh, so I first merge spawn generator HP, which I had previously worked on. It had some updates to the files components.h, init.cpp, main.cpp, render.cpp, spawn.cpp, and update.cpp. 80 insertions, 39 deletions. Make sure that there's no other branches other than master at the moment on my local end. And I open up to do, and I take some notes about things I just took care of. We can actually speed up the video a bit. That way I'm not forcing y'all to watch a bunch of unnecessary stuff. So we're introducing spawn count to our generator component now. This will allow us to add a spawn count variable on generator events. What this means is we can create a generator that, for instance, would only spawn bats 10 times and then stop generating entirely. Similarly, we can also set the spawn count to a special value, such as -1, in order to indicate that it should infinitely spawn forever until some other event turns the generator off. We set up the code to handle this by checking the value stored in the spawn count variable. If it's greater than 0, then we can just use that as our value and decrement every time we perform an event. Otherwise, if it's -1, we want to spawn it forever. So here we're testing it out by spawning some eyeballs. We go to make sure that our if statement is correct. And we only want to decrement if it's like greater than 0, right? Like if it's a -1, you don't want to actually mess with that variable anymore because that's a special value. So we handle that with a second if statement. And now we can test out spawning actually works. At the moment, all we have are bats and eyeballs. Later on in this video, though, we're going to introduce a goblin, as well as a bunch of other things. I kind of want to rewind this gameplay and slow it down a little bit. But here I'm demonstrating spawn groups. You notice that each bat is moving at a different speed, and this is because of the way that the spawn bats function works. Whenever you spawn a group of bats, each one of them is assigned a randomly selected X velocity from certain ranges. Their positions are also randomly selected in a way that allows for the groups to vertically appear at different rows, essentially. What's kind of evolved with the mechanics of the game over time, this wasn't a conscious design decision, but in realizing what has emerged, I'm trying to center more of the gameplay around kind of like very precise movements and precision attacks and things like this, so that it's not just your typical bullet hell game. There has to be some level of intelligent movement and thought put into every action that the player does in order to maximize your ability to survive. That's what I want to go for. But at the moment, things are kind of easy. We haven't figured out exactly how to tune the spawn rate in such a way as to maximize not only the difficulty but the enjoyment of the player. So at the moment, we're testing out adding multiple generators with the same enemy type so that we get a wave of one bat and then two bats and then three bats and then four bats. And we can offset the beginning of each wave such that only one group appears every so many frames. So we start with one bat. Then we get two. Then we get three. Then we get four. That's pretty sick, right? Homegrown. Built from scratch. Eggs and bacon omelets. Fuck yeah. God, I'm hungry. I guess it's about time to make some lunch. But I'm going to finish annotating this section first. Now we're playing around with the frame begin to get it correct so that we get a wave right away. That way, the first wave starts on frame 0. And then every subsequent wave starts at a multiple of 5 seconds or 300 frames. Depending on how fast the frame draw is, technically speaking, 300 frames may not necessarily be 5 seconds, but the assumption is that you're running near 60 frames a second. And doing things in terms of frame begin and end is kind of an interesting way to think about things because you kind of quantize time that way. Let's take a little break here. All right, let's see where I left off. All right, I was spawning groups of bats with different numbers of bats per group. We go ahead and add everything to our check-in, dynamic generators. In other words, being able to vary the parameters in such a way as to give us a lot more customization over how many enemies we generate at one given time. One of the end goals is a programmatic approach to scripting out enemy waves. Pretty soon we'll be able to even add generators to JSON files and script them out that way so we're not doing so much hard coding in the actual game. Speaking of, that's what I'm starting to do right now. I've created a generators.json in preparation for actually parsing such a file. So, given what I actually have in a init game at the moment, where I create generators for both eyeballs and bats, I use this premise to come up with a mock JSON file to specify what generators we want to actually create at the beginning of the game. Why is this important? Why would I even want to spend time doing this? Well, like I was saying, this gives us a lot more flexibility and customization over our ability to specify exactly when certain enemies get created and appear on screen. So at the end of this whole process, we're going to have the ability to dynamically specify what enemies appear and when without ever having to rebuild the game. And that's huge. That's an incredible step towards full blown procedural generation, which is one of the end goals of this project. There's a number of different ways to go about doing this, but in the very beginning, we can specify these parameters to begin with. We have the key, which is going to represent what type of enemy. We have a number of different things, and I haven't realized it at this moment, but what I'm writing is not valid JSON, so the parser's going to yell at me. And actually, I discovered a small bug in how I am using rapid JSON in order to actually read and parse JSON files. But in this process, I go ahead and I write a new function in load.cpp called load generators so that we can actually pull in the generators from a file. This works the same way that we're handling textures as well as the main game configuration. Eventually, I'm going to go back and redo how I'm doing the main config. Someone kind of clued me into the idea that writing custom struct and accessing a global that way might be much faster than utilizing a standard template library map or something like that. So I'm first debugging load generators at the moment, and eventually I'm going to realize that the thing that I have in the center of the array is not actually a valid JSON object. It's actually not even a valid dictionary. So I'm going to end up having to rewrite this whole thing so that we have keys and values rather than just values. If it were an array, this would work, but we want to be able to intelligently access the parameters that we're working with. So I try to force it into an array. I realize that doesn't work. And then I go back and I start from scratch again in order to actually specify the keys and the values for all of these different parameters. But each one of them is essentially a parameter that gets passed to spawn generator, which makes this a pretty straightforward process once I get past these initial hurdles. Let's go and fast forward a little bit. As you can see, I am specifying the keys. Because I have such terribly short-term memory, I have to flip back and forth between the files pretty frequently in order to get those all nice and tidy. For some reason, it didn't like that initially either. So, plow through these errors. I use the initial config JSON as a basis. And then I realize I need to do some Googling. I find on Stack Overflow something about needing to zero out the array of characters that you read your file into before attempting to parse it, and this actually 100% fixed my my problem. Now we're ready to use the actual oh god, there's my Robert Kennedy voice coming out there. Now we can actually use the real JSON values. So to verify that I'm reading them incorrectly, I print them out, but we go ahead and rewrite that entire JSON config. So I got type, we've got group number, we've got cooldown, we've got cooldown reduction, spawn count, frame begin, and then hit points and position. So you can specify all of these different values on generator creation in order to start customizing how enemies spawn in the game. This would be basically one step towards custom level generation. So in the end, being able to procedurally generate the generators themselves, among other things. Imagine that, a generator. A lot of this code is very straightforward. Um, we just go through and we check to see if the JSON object has all of the required keys, and then we copy those values into real variables that can be passed through the function spawn generator. I probably could use more error checking on certain things, but everything works at the moment. I go and make sure that I'm printing out and grabbing the correct values when we actually create the generator, and then we comment out the old code to make sure that the new code works, and sure enough, it does. So we pull out the type, and we add another generator to our generators.json in order to test out loading multiple enemies. And there we go. A little bit of cleanup. Make the code a little bit nicer. Condense it a bit so that it's not so hard coded. And everything still works. And there's our commit message. We merge it over. And then I'm going to realize that I probably need to delete the old build folders before it'll actually correctly compile again. But here I'm actually wrapping up a lot of the code into separate functions. So anytime we encounter an object of a certain type in that JSON file, we call one function or another. In other words, handle bat generator and handle eyeball generator. So that we can customize how we handle them if we need to, but they both get triggered at the same point in the whole process. We parameterize scale so that we could also custom specify how big or small the generated enemies are. So we can actually create giant eyeballs and bats now. Anytime we want to add another parameter, all we have to do is update our JSON file and then add the correct code to the parser and handle it appropriately. So this is all the results of JSON configuration at the moment. It works pretty good. We're going to go and make our commit for scale. And I'm going to pause for a moment. We'll get back soon, but now it's time to create a goblin character. I'll show you all how to create and add an enemy. All right, now it's time to create and add a goblin character. I drew this guy up a little while ago. I'm going to extend him so that we have a winged version, and then I'm going to add the original version to our game. And then I'm going to make them fire bullets upwards over the y-axis at the player. not locked onto the player, but just at the player. I feel like there might be a future in spriting content, as I had fun actually making this, and I think people seeing visuals of making sprites would be popular. So I first start by drawing a really shitty wing. Not just because it's brown, but because I'm a terrible pixel artist. I eventually realized that I should have done it on a separate layer. And so I copy and move the wing in such a way as to not lose anything, but allow me to copy it over to a separate layer so I can set it behind the goblin instead of attaching it directly to him. So now we got our separate layer and it's behind. And so you can see I can move the goblin on top of it. We copy it and we flip it so that we have two wings now. And we can put the goblin right on top. Now, we want to copy the animation from the original one so that this goblin also does the little stampy motion, right? So, because it's a walk cycle, we want 4 frames, standing, 1 foot, standing, and then another foot. We've got 4 frames now. And we make the wings move along with the goblin to give the appearance that they're actually jiggling. It's got a little nice jig here. So now we play around with an eyeball as well. I don't integrate this one directly into the game yet, but I had fun kind of making an eyeball that opens and closes with a transparent effect around them so that we'll be able to drop this onto various backgrounds and have really cool open close eyeball effects happening. I think that's going to make the game look like really sick, and is highly inspired from the anime Hellsing, which I was a big fan of in high school. Alucard is a fucking sick motherfucker. But I digress. So we go ahead and do a little touch-ups here as we're making each new frame forward for the open and close effect. And now we have transparency around it. So we'll be able to drop this onto any color background and it'll still look really cool. Maybe even not necessarily colored backgrounds, but backgrounds with other things in them. So now we're going to go and export the goblin and get him into the game. I'm going to tweak up the canvas on this one before I do that, though. And now we have sprite sheets for all 3 of these different entities that will be in the game. Now it's time to actually put in the goblin enemy. So first things first, we go over to our texture.json and load up the goblin sheet. We do one version, which is the regular, and then we do one that's color modded red to indicate when he's been damaged. Just like with all the other enemies, we create a new function dedicated to spawning the new enemy in a similar fashion, specifying the XY start position as well as the VX, VY velocity, among a couple other parameters, such as screen position. But at the moment, we're just going to make them come from the bottom right, walking towards the player to the left, and they will be eventually firing bullets, but first we have to get them on the screen and get them moving. Now we've got a goblin generator, so we can hopefully be able to just drop the goblin definition into the generators file and have everything appear correctly. I realize I used the incorrect name for the sprite file, and I correct that. We add a new enemy type called goblin, and we add appropriate handling code to the generator parser. Still no goblins yet, but start playing around with some of these numbers to see if we can get them to appear. Something's not triggering. I realize I forgot to add the code for the handle goblin generator, but now it's the tedious task of tracing the flow of execution in order to find where something is or isn't. For some reason, spawn goblin's not actually getting called. So I start doing some printf style debugging in order to try to figure this out. Eventually, I realized they're being removed from the screen prematurely early, I think. During the update generators loop, we go ahead and print out what the generator type is. So this should actually get called rather frequently. We've confirmed we're actually spawning the generator, but for some reason, something's not getting triggered. I confirmed the frame count is actually getting called. And then I verify that spawn goblin is now indeed being called, but we still don't see any goblins. So what the fuck? I print out the rest of the variables being passed in just to get an idea, and I see, oh, the goblin is pretty far off screen. It's also moving very slowly. That's why we don't see him right away. Now we see him moving from the left. Let's go back and actually watch that again. So there's our goblins. But they're going left to right, not right to left, so I gotta fix that. By default, the goblins are only going to appear on the right. So first we're going to go and update their position on the y-axis. There's a flip-flop that occurs with the VX direction, though. At some point in the code, to indicate negative direction, you have like -x. or minus Vx. And it gets multiplied depending on what you pass in. So they're still a little bit too far off screen. But now we should have them moving in the correct direction. Now, that's a fun discovery, is that when you fire the knives at them, the position of the knife by default, unless it's actually, even if it's spinning, it probably wouldn't still hit. I also noticed that on Game Over, for some reason, the goblins aren't reappearing. I get them to reappear by rebuilding the game, or rerunning it, rather. And we want the goblins to be appearing just enough off screen so that it doesn't look like they're just popping into existence. But this should provide an additional annoyance for the player if they're trying to hug the bottom of the screen in order to avoid the bats and the eyeballs. They'll have these goblins to deal with now. Of course, anyone who's watched enough of this game development series will have seen that we've added in a shotgun spread effect to the skull, which would allow you to actually take out the goblins pretty easily once you get it. So let's continue. I now have to figure out why the goblins weren't reappearing, and it's because load generators wasn't being called on a init game whenever we have a game over. Now we should actually see that. So yeah, now the goblins are showing back up. Whenever you game over, the data structures get cleaned up, but if you restart the game, everything reloads. All is right in the universe. Let's get all the enemies up in here. Party time. Let's speed it up a bit. Something's up with the eyeballs. There we go. Big eyeballs. Hell yeah. Lots of goblins, lots of stuff happening. This is pretty much where we're at. But there is a little bit more extra work that I've done in this video that I want to showcase. What you don't see yet, but I'm going to show y'all, is that we now have the goblins firing bullets. Little pink square bullets that spin up at the player that the player has to dodge. We'll get there. And actually playing around with the video speed up during the development of this series leads me to another idea for a future power up or difficulty increment by actually speeding up all of the in-game movement values. Kind of like hyper mode and Vampire Survivor. All right, time to commit all that old code, because we now have goblins. Let's merge over our branch, delete the old branch, and everything's... Oh. The game needs to be rebuilt, but I have to clear out the cache because it's still operating with old object files. It takes me a minute to realize this, so have some fun watching me squirm for a bit. Like, I started freaking out, really. Like, I was really fucking confused as to what the hell was going on with my build. I just wrote all this code. Why wasn't the code running? I go back, I verify that I actually did write everything that I just wrote. Seriously, you have to really think about your preconceptions as to how things are supposed to work. And what I realize is that I actually have to delete the CMake build cache folders in order to get the build to correctly build again. So watch me figure this out. Yeah, at this point, like, I'm actually freaking out. That's exactly what was going through my head. It's like, am I going insane? And I think when I get this error that you just see on the right over here, this is what indicated to me. Oh, whoops. The cache files are probably out of date. I should probably delete the old object files. I still make sure that the extern is defined, and it is. Because I'm dumb, I repaste it, comment out the old one, even though it's exactly the same code. Because I thought anything is worth trying at this point. But now you can see me type rm-rf build/cmake star, and we're all good after that. And we also delete the dot cache, and everything is actually fine now. God is in his heaven, all is right in the world, and the goblins are back. We go and check in our code, even though I didn't even do anything. And actually, that's all I had recorded. But we do have enemy bullets now. It might be in some other video, but this is probably long enough. We'll do another update in a similar fashion here pretty soon, but I do have to write more code and make more video for that. Plus, I think y'all might be entertained if I start making a habit of putting some cool graphics and meme images on top of the videos before I actually upload them. So I hope that this was a good update for you guys. If you really enjoy following this game development journey, please like and subscribe, share with all your friends, family, coworkers, fellow game developers, C++ programmers, Linux nerds, tech hobbyists and enthusiasts. Y'all are all my target demographic, and I know there's a lot of you out there. So join up. It's a fun time. And take it easy, everyone. Have a great day.